Hello and welcome back to the series on Python and spaCy, named entity recognition, all for digital humanities. In the last video, we looked at how to actually take our training set that we cultivated with the spaCy entity ruler and train a custom HP Harry Potter NER model. And we saw that we added an NER element or pipe to the spaCy pipeline of a blank model. In this video, we're going to stop really working with code and move into something that is a bit more conceptual by analyzing what spaCy's models look like under the hood. And to do that, we're going to just write a little code real fast. We're going to say NLP is going to be equal, or sorry, we're going to say NLP is equal to spaCy dot load, and I'm going to load in one of the standard models to demonstrate what it looks like. And because I don't want to have a lot of space, I'm just going to use the small model here. And then what I'm going to do is I'm going to say nlp.toDisk. I'm going to use the toDisk function, and I'm going to save it as nCoreWebSM That's just so that it doesn't overlap with the actual small model. And this is going to be important for demonstrating why our model is good and also where it can be improved. And to demonstrate that a little bit better, I'm going to jump ahead to a bit of code that I've prepared for video 6 in this series when we start to look at the problems with off-the-shelf spaCy models a little bit more closely when it comes to named entity recognition for domain-specific tasks. So here we have a bit of code where it's just going to print off all the different people that our model finds from this test text and compare it to all the different people that the spaCy large model, so the really good 780 megabyte model that spaCy has. And it'll take a second to load because while our model is small, the 780 megabytes will take a second, and there it's already done. So if we look at these two results, we see that the first initial results are pretty similar. Both models have grabbed Harry James Potter, both have grabbed James, both have grabbed Lively Potter. Ours, however, has grabbed the word Phoenix. Not entirely sure why. Perhaps there was something in the training set that actually had Phoenix in it. Maybe because of Forks was pronounced as Forks the Phoenix in our entity ruler. I have to go back and check. But if we go down this list, we see that our model starts to perform a little bit better on certain domain-specific things. So the spaCy model correctly identified Neville Longbottom, Harry, but it gets here and it has identified Voldemort singularly. It has missed this entity, Lord Voldemort, and I've already gone through to make sure the numbers line up. So Lord Voldemort appears right here. The spaCy LG model missed that entirely. It did find this one though, and we see that right there. Our model found both this Lord Voldemort as a single entity, so Lord and Voldemort, because that's a single entity, that's a single person. He's referred to as Lord Voldemort consistently throughout the book. And we also see Voldemort here going on down the line, and this makes me think that maybe I should include in my entity ruler, he who must not be named. Things like that, these super Ks that refer to Voldemort. I'm not sure that those were in our training set. I'd have to go back and look. But that's something that you do when you're training an NER model. You look at the results and you think about how you can make adjustments to make it perform better. Your goal is to get as close to 100% accuracy as you can, but that's going to be unobtainable. Sitting around 95% accuracy is considered quite good, 97, and you're looking at a state-of-the-art domain-specific model. So if we keep on going down the list, we see that our model does vary. And in fact, the number of entities that our model has identified compared to the spaCy model is, I think we have 3 more that the spaCy model doesn't have. But the spaCy model is able to find things that our model can't find. For example, it has found Cedric Diggory as a person. Why has our model failed to identify this? It comes down to 2 things. Cedric Diggory's name doesn't appear, I don't believe, anywhere in book 1 of Harry Potter. He's not introduced until a little bit later in the series. And of course becomes one of the main characters or main secondary characters in book 2. However, the spaCy model has not read Harry Potter, and yet it's been able to identify him. Why? Because the spaCy model was able to do what we call generalization. It was able to generalize well. And why is this possible? Well, in order to understand that, we need to look under the hood of spaCy. So I'm going to open this up in my actual Windows Explorer so we can explore this in more depth, because this is going to be a little illegible for those of you looking on smaller screens. And if we open this up, we can do right click and add them, and it allows me to open up an actual Windows Explorer. I can zoom in and we can look more closely at everything. So if we're looking at this, we notice that we can open up the spaCy demo that we saved. And in this file, we've got a few different folders. We've got an NER pipe, we've got a parser pipe, a tagger pipe, and vocab folder. Now, these are actual pipes in the spaCy models pipeline. In order to perform NER, the text needs to be parsed, needs to be tagged, and then it passes to the NER and the model. I'm going to jump in and look at a couple of these things in depth. The first thing that you'll notice is this meta.json file. I'm going to pull this to the side for the second and actually open up the JSON file here. If we open it up, we have clearly a dictionary, right? So it starts off with the dictionary opening and it'll end with the dictionary closing. So standard JSON format of a dictionary. You have a couple different important pieces of metadata up at the top. You've got the language that it's in, you've got the name of the model, you got the license, you got the author, a URL that'll link to the actual team, a description of what the model was trained on. So this gives you a little bit of context for how it was trained. And you've got some sources where they got that training data. And then it tells you what's in the pipeline. A pipeline is going to be a series of steps in which data is processed or manipulated. And the further down in the pipeline you go, the more that the earlier stages in the pipeline affect what happens at the next stage. I hope that makes sense. I'm going to explain that in a lot more detail in a later video. And then you keep on going down and it gives you kind of the accuracy benchmarks and all of this for all the different things it's able to detect. And if you keep scrolling down, I'm going to scroll down this way now. It's going to take me a little while. You get to its speed and you get to N words. N words tells you the number of words that are in the model's vocabulary. And I want to make a very important distinction. Number of words does not necessarily reflect the number of word vectors. spaCy models, when you're training them, will add new words that it encounters to the vocabulary, but it won't automatically add vectors to the word vectors. And we're going to see that in just a second. The next thing you get to are the different labels that can be assigned to in different stages of the pipeline. When we get down to the NER pipeline, we can see it right here. We see that we have all the different labels that the model is able to recognize. I believe there's 18. So you go from cardinal numbers, dates, events, FACs, GPEs, language, law, lock, etc. on down the list, person. And that tells you everything that the model is able to label. And there'll be different accuracies assigned to each of those labels. And then you get to kind of this area here where you get to the vectors. Now notice here that we don't have any vectors represented. Well, what are the vectors? Well, if we open up spaCy, we can look at the vocab folder, pull it over here under vocab, and you get to this little file right here called vectors. Now you need to open it up in something like Atom or some kind of advanced notebook reader. You also have a file called strings.json. Strings.json is going to be all of the vocab that the model has encountered, and that's going to allow for the model to generalize in theory well on unseen data. Now, if we go down the list, we can see all of that. However, we don't see anything in the vectors. So what I'm going to do is I'm going to load in the spaCy LG model, which actually does have word vectors present. And this is going to take a little bit longer because it's opening up that 780 megabyte file model, and it's saving it now to my directory right here. And now if I open up vocab, I'm going to see a lot more represented underneath vectors. It's going to take a second to load because you're going to see why in just a second. This is a massive text file. The 780 megabytes, this is where a lot of that space is coming from. It's a giant text file of word vectors, which are matrices of matrices. I'm going to talk about word vectors in the next video in a lot more detail. For right now, we're just going to take a cursory look at this element that's under the hood of spaCy. So this is what the word vector file looks like. Now, this is illegible to us, but it makes total sense to spaCy. What these are matrices of matrices, or mathematical representations of word vectors. What we care about right now, however, these two pieces of information. The shape of the word vectors. Now, these two numbers are very important. We're going to see why when we start working with vectors and training a word-to-vec model, exporting word vectors and importing them into spaCy. But this first number up here, this 684,831, that tells you the amount of words that are represented in the vectors. So there are 684,831 different words or characters represented in these vectors. And the second number tells you how much or how deep the vectors are. So in this case, we have 300. Now this means each word or each character, each vector has 300 different dimensions. This is the way in which the model understands word similarity. And this is instrumental in training machine learning models for the purposes of NER, because having good word vectors that are domain specific radically increase the accuracy of NER models. And we're going to be doing that over the next few videos. And if we go down to our, for this large model, and we pull up the vocab, we see that the vocab, still a lot of the same stuff there. You got all your words in there. If we go down to our metadata file for the large model, so we can see it right here, core_web LG, we can see a lot more detail in the vector area. I'm going to slide it on down for you. So here, under vectors, we have a bunch of very important information. The first thing we have is the name of the vectors. So in core web lg.vectors, that's going to link up to the actual vector space under vocab. And we have three other pieces of information that we didn't have before with the small model. We've got the width, which is going to be the depth. So there's 300 dimensions. We've got the vectors, and we've got the keys. Now, you will not always see vectors and keys look the same as you train NER models that are off the shelf. And the reason for that is because as the NER model encounters new words, it's going to add new vocabulary and new keys, but it won't add new vectors for those words. So that's something to pay attention to. So that's going to be really kind of what's happening with spaCy under the hood. These are what these files look like, and these are what these files actually mean. I encourage you to spend some time and just explore them. If you damage them, it's not going to be a problem because you're not affecting the main spaCy model. Save it into another directory and just explore it. And you will also notice that within the NER model, we're going to see this a lot more in the future videos, but you also have this CFG file. So I'm going to open up the CFG file right here. And this is going to become a lot more important when we start adding new vectors in. But this is going to tell the NER model kind of where the actual word vectors are that are pre-trained. This is going to become very important when we start to try to get our model to generalize better on domain-specific data. So in our case, Harry Potter. And once we get past all of this, we're going to start exploring this process with a real-world example in two different domains. One for the Holocaust and another for medieval Latin. The idea there is to serve two different sections of scholars who might benefit from two different kinds of problems that happen with domain-specific data. Again, we're going to get to that in future videos. But hopefully now you have a better sense of what the spaCy model actually looks like from a folder point of view and what some of these files actually refer to. And the model, which you'll see underneath the NER folder, is, as you might have guessed, the actual model. If you open it up, you're not going to be able to make any sense of it because it's going to look like this. But it's the actual model file that is kind of the trained model that comes with spaCy that performs the NER. So when you create the spaCy pipeline and you create the NER model, that's what you're adding to. And every time you train an NER model, that's what you're actually training. So that's going to be it for this video. Hopefully you have a little bit of a better sense of what the actual spaCy models and pipelines look like in a folder setting. And I promise you, even though we didn't do a lot of code in this video, this is going to make a lot more sense and be a lot more helpful in the next few videos as we try to train custom word-to-vec models, import those word vectors, and actually start to do some much more sophisticated and robust things with custom spaCy models. That's going to be it for this video, though. If you've liked it, found it informative, please like and subscribe down below.